Hi, fifth graders. Today we are going to be doing the Chapter 11 review. This can be found starting on page 705 in our textbooks. So for question number 1, Fran drew a triangle with no congruent sides and one right angle. Which term accurately describes the triangle? Mark all that apply. So I'm going to make sure I underline the information that I'm going to need to use for my side length classification, and then my angle classification. So working with the sides first, I noticed choices A and B are going off of side length names. So isosceles, if you recall back in lesson 2 when we were working with triangles, isosceles means that we have two sides that are congruent. And my hint for that lesson was you have two eyes, and when you say isosceles, there are two sides that are congruent. The other choice is scalene. If you recall from lesson 2, scalene is all sides are different, so 0 congruent sides. And remember, congruent means that they are equal to each other. So going back up to the question, it says 0 or no congruent sides, so that would be choice B. Now I'm going to do the same thing for the angles. So up in the question it says that there is one right angle. Well, we know from lesson 2, if there is one right angle, that would make it a right triangle. So I had to have both B and D selected for question number 1. If it was equilateral, remember all three sides would be congruent. Or if it was obtuse, you would have one obtuse angle. Obviously, in an acute triangle, all three angles have to be acute. Moving on to question number 2. Jose stores his baseball cards in a box like the one shown. It says, use the numbers and symbols on the tiles to write a formula that represents the volume of the box. Symbols may be used more than once or not at all. So on the test on Schoology, we already have the volume equals done for you. There will be blanks that you will be filling in to represent the length, the width, and the height. The multiplication signs are already there for you as well. So looking at the box, I see that it has a length going side to side of 8 inches. The width, remember the width is how far back or how deep the box is. So it goes 10 inches back. And then the height is how tall that box is, and we have 3 inches. So those are the numbers that I would fill in for my formula. Volume equals 8 times 10 times 3. And then the last step is we have to find the volume of this box. So when I multiply 8 times 3, I know that that equals 24. And then 24 times 10 gives me 240. And that would be in cubic inches. So for your test, that will be a question that's worth 4 points. Number 3, this says Mr. Delgado sees this sign while he is driving. For A and B, choose the values and term that correctly describes the shape Mr. Delgado saw. So this is going back to lesson 1, where we have to just figure out how many sides, and it is missing a word. It would be angles or vertices. Right here we'll say vertices. And then we would have to then say if it was a regular, not regular, or not a polygon at all. So for A, I see that this picture has 3 sides. So if it has 3 sides, it also has 3 vertices. Remember, the vertices are the points in which your sides meet. If it had the word angles instead, it would still have 3 angles, because if you have 3 sides, you have 3 angles, and you would also have 3 vertices. And then for B, all of the sides are congruent, so the figure is, if all sides are congruent and all angles are congruent, it would be a regular polygon. Remember, remember to be regular. All sides and angles are the same or congruent. Moving on to the next page, number 4, they want to know what is the volume of the composite figure. So this was back from lesson 11. So I'm going to work from the bottom prism on up to the smallest prism. So I see that the length of this bottom prism is 6 feet. The width, remember, is that diagonal line or this line slanted back. I don't have a number that is associated with this bottom prism, but I see all the way up at the top, it tells me that diagonal line is 3 feet. So my width is going to be 3, and I can go ahead and say that it would be 3 for every single one of these. And then the height of my bottom prism, they tell me that information right here, and it is 1. So my largest bottom prism, I would have 6 times 3 is 18. 18 times 1 is still 18. Now for the middle prism. So I need this length right here. And they do not give me that number. However, they do give me the information to figure this prism length out. I know the bottom prism is 6 feet long. They're telling me that the length right here is 2 feet. So therefore, I would have 6 minus 2, and that would leave me 4 feet for the length right on that middle prism. If you recall, we said the width will be 3 for all of them. And then the height, again, they give me that information right there, and that is 1 foot. So I have 4 times 3 is 12, times 1 is 12. And now for the little prism. Again, they are telling us for the length, for the middle prism, we had 4 feet. Well, this piece right here, they're telling us is 2 feet. So therefore, this missing length right here, we know 4 minus 2 would be another length of 2 feet. The width is remaining a 3, and the height, again, we see is 1. So 2 times 3 is 6, 6 times 1 is 6. So now we can add these together. I know 18 plus 12 equals 30, and then 30 plus 6 would then be 36. So my final answer is 36 cubic feet. Moving on to question number 5. It says match the figure with the number of unit cubes that would be needed to build each figure. Not every number of unit cubes will be used. So for this first one, I'm going to just look at the bottom layer first. So I have 3 cubes on the front, and it's 2 cubes back. So on the bottom layer, 3 times 2 is 6. Then I can't do the same thing for the top layer because notice we're missing 2 cubes right on the top layer. So if I have 6 on the bottom, I'm just going to add how many are on the top. So I see 1, 2, 3, 4 on the top layer. So I have 6 plus 4, which would be 10 unit cubes. So I'm going to match that. On Schoology, you will be dragging that 10 up to match straight across. The middle section, the middle prism, I see it has a length of 3, a width of 2, and a height of 2. And it does not appear to have any cubes missing, so I'm just going to multiply my 3 times 2 times 2. Well, I know 3 times 2 is 6, and 6 times 2 gives me 12. So I have 12 unit cubes for the middle prism. And then for the bottom one, this one we can easily see that we just need to count all of the unit cubes. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 unit cubes on the bottom prism. So that question will be a 3-point question on your test. Moving on to number 6, it says Chuck is making a poster about polyhedrons for his math class. He will draw figures and organize them in different sections of the poster. So we have to make sure we remember what a polyhedron is. And a polyhedron, if you recall, is a 3D figure made up of all polygons. So part A, Chuck wants to draw three-dimensional figures whose lateral faces are rectangles. So we have lateral faces that are being rectangles. He says he can draw prisms and pyramids. Do you agree? Well, I have to remember a prism lateral face and a pyramid lateral face. So remember, prisms have two bases. And with those bases, they are connected with rectangles for their lateral faces. And now doing the same thing for the pyramids. So a pyramid has only one base, and the lateral faces that meet up at that point of the vertex, those are triangles. So it has triangular lateral faces. So knowing this information, I can now say if I agree or not. And in part A, it says he can only draw those with rectangles for their lateral faces. So no, I do not agree. Because pyramids have triangles for their lateral faces. He can draw prisms only. So again, if he can only have lateral faces that are rectangles, he can only draw those prisms. The pyramids have triangles for their lateral faces. Moving on to part B, Chuck says that he can draw a cylinder on his polyhedron poster because it has a pair of bases that are congruent. Is Chuck correct? And explain your reasoning. Well, we've already said that a polyhedron is a 3D shape that is made up of all polygons. A cylinder does not have a single polygon on it. Remember, a polygon has line segments to form those sides. A cylinder has all circles or curved surfaces. So no, a polyhedron is made up of all polygons. A cylinder does not have a polygon for any side. So again, no cylinders can be drawn on his poster because a cylinder is not a polyhedron since it does not have polygon sides or faces. Moving on to the next page. Number 7. Javier drew the shape shown. For A through B, choose the values in term that correctly describe the shape Javier drew. Well, they want to know the figure has how many sides and how many angles. So if I count this, 1, 2, 3, 4, 5, 6, 7, 8, I see that there are 8 sides. And if you recall from lesson 1, if you have 8 sides, you will also have 8 angles. So that is worth 2 points right there. And then for B, they want to know what the name of that polygon is. Well, I know a 8-sided polygon is an octagon, and obviously it is regular. So that would be the 3rd point for that question. Moving on to number 8, Victoria used 1-inch cubes to build the rectangular prism shown. Find the volume of the rectangular prism Victoria built. So we know that we're just finding the volume by taking our length, which we see is 6 inches, times our width, which is 3 inches, times our height, or how many layers, which is 4 inches. So we can multiply in any order that we choose. So I'm actually going to take 3 times 4, which is 12. And then I'm going to multiply 12 times 6, because I know 12 times 6 is 72. So 72 cubic inches for her volume. Moving on to question number 9. Nathan drew a scalene obtuse triangle. For 9A through 9C, choose yes or no to indicate whether the figure could be the triangle that Nathan drew. So to be scalene, we've already talked about this back on question number 1. Scalene has 0 congruent sides. And then to be obtuse, you have one angle. Oh, sorry about that. To be obtuse, you have one angle that is greater than 90 degrees or less than 180. So, looking at my 3 triangles, for A, if I could use a piece of paper if I don't have a ruler, which you will not have a ruler on your test, I could easily mark and notice that all 3 sides are different than any of the others. So I have 0 congruent sides for A. Now I have to check to see if I have an obtuse angle. Well, if I use a corner of a piece of paper, I notice that this angle is larger than 90 degrees. So because it is larger than 90 degrees, yes, this is a scalene obtuse triangle. For B, again, you could always use a piece of paper, but it is easy to tell. All 3 sides are different, so right now it is scalene. And again, you could use the corner of a piece of paper if you needed to, but you would notice that this angle right here is greater than 90 degrees as well. So yes, this is also scalene obtuse. And for C, right away, my first thing that I'm noticing is there is a 90-degree angle down here in the corner. And because I have a 90-degree angle, I know it is not obtuse. So no, that is not scalene obtuse. It is still scalene, but it's a scalene right triangle. Moving on to the next page, for question number 10, it says a shipping crate holds 20 shoe boxes. The dimensions of a shoebox are 6 inches by 4 inches by 12 inches. For A through B, select true or false for each statement. It should actually be A through C. Select true or false for each statement. All right, so for A, each shoebox has a volume of 22 cubic inches. Well, we know that it's a 6 by 4 by 12. So 6 times 4 times 12. If I would multiply that out, we know for sure that that is not 22 cubic inches without doing any math. But we're going to go ahead and show this math anyway. So I'm going to take 12 times 6 which I know is 72, and then 72 times 4 to get the shoebox volume. So 4 times 2 is 8, 4 times 7 is 28. So I have for one shoebox, I have a volume of 288, so that was false. Now for B, they want to know, each crate has a volume of about 440 cubic inches. Well, I know the volume of one shoebox is 288. I know that there are 20 shoeboxes. So I'm going to take 288 times 20. So I'm going to drop my 0, and then I can just do 288 times 2. So 8 times 2 is 16, carry my 1. 8 times 2 is 16, plus 1 is 17, carry my 1 again. 2 times 2 is 4, plus 1 is 5. So that one would also be false, because we just found that a crate would be 5,760 cubic inches. Finally, for C, if the crate could hold 27 shoeboxes, the volume of the crate would be about 7,776 cubic inches. Well, we're going to take the volume of the one shoebox, which was 288, and we're going to multiply that by the 27 shoeboxes this time that they said that we would be using. So, move my screen a little bit. Go ahead and multiply. 8 times 7 is 56. 8 times 7 again is 56. 56 plus 5 is 61. 7 times 2 is 14. 14 plus 6 is 20. Cross everything out that I'm finished with. Drop a 0. And now I'm going to multiply the 2. 2 times 8 is 16. Carry my 1. 2 times 8 plus 1 is 17. Carry my 1 again. 2 times 2 is 4, plus 1 is 5. Now I can add these together. So 6, 7, 7, 7. So that one is true. We did get 7,776 cubic inches. Moving on to question number 11, I am going to make a little bit of a modification. My first thing is I am going to cross this box out. And now to go into the question. It says Mario is making a diagram that shows the relationship between different kinds of quadrilaterals. In the diagram, each quadrilateral on a lower level can also be described by the quadrilaterals above it on a higher level. So for part A, they want us to complete the diagram by writing the name of one figure from the tiles in each box. Not every figure will be used. So we know that we are starting with the quadrilateral. My picture is different. I'm so sorry. So I do not need to take that one away. So for this picture, I have the quadrilateral, and we are going straight down. If you remember from lesson 4, when we are working with the quadrilaterals, after the quadrilateral group, we then went into the parallelogram group. The parallelogram. Then inside the parallelogram circle, we could then go to the rhombus circle. And then obviously part of the rhombus circle would be the square. So that is the Venn diagram in a flowchart. Now for part B, Mario claims that a rhombus is sometimes a square, but a square is always a rhombus. Is he correct? Explain your answer. So if you look back up at that flowchart, you do see that a square is always going to be inside that rhombus circle, but we have to remember that not all rhombuses can go into the square circle. So yes, a square is a rhombus because it has 4 congruent sides that are parallel to each other. Now, a rhombus is not always a square because a rhombus does not always have right angles. So in order for that rhombus to become a square, it must have those right angles. And if you recall from that lesson, we did not always have right angles for each of those rhombi. Moving on to the next one. Number 12, write the letter in the box that correctly describes the three-dimensional figure. So notice we're comparing between prisms and pyramids. We've already discussed the difference between two. The pyramid is probably the easier one because the pyramid comes up to the point at the top and it only has that one base at the bottom. So I notice that for A, I only have one base at the bottom and then I have that vertex up at the top. So A is a pyramid. Same with D. I notice that I have one base at the bottom and it comes up to one point at the top with those triangles that meet up at that vertex. So for B, my prism, I do need 2 bases, which we can easily see my 2 bases. And then those 2 bases were connected by rectangles for those lateral faces. And then C, we know that this would be called a cube, and a cube is also a prism. Moving on to number 13, Mark packed 1-inch cubes into a box with a volume of 120 cubic inches. How many layers of 1-inch cubes did Mark pack? Well, remember, we are using the formula volume equals length times width times height. We know the volume is 120 cubic inches. We can easily find the length by taking 1, 2, 3, 4, 5, 6, 7, 8, counting 8 cubes, times, again, we can find that width by counting 1, 2, 3, and the layers is the height. So now what I want to do is I want to multiply to get that base area. So 8 times 3 is 24. And we know that we have to figure out 24 times what missing number will give us my 120. So this is essentially a division problem. So I now have to figure out 24 times what gives me that 120. So this is going to be more of a guess and check. So I'm going to actually round down to 20 to try and guess what number I would want to start with. I know if I have 20 and I multiply it by 6, that's already 120. So I know 6 layers is going to be too much, so I'm actually going to just bump it down 1, and I'm going to try 5. So 24 times 5, well, 5 times 4 is 20. 5 times 2 plus 2 is 12. That does give me my 120, so I can easily see that it is 5 layers for this prism. Moving on to question number 14, we have another composite figure. Again, however you choose to cut this prism up is up to you. I'm going to try and make it so that way there's not as much work that I'm going to have to try and figure out my missing numbers. So for me, I notice that it's probably going to be best if I break them where I have a little box on top of a bigger box. So I'm going to work with the larger prism because I do see the length is 10. I see the width is 6. And that my height is 4. So if I multiply this together, 6 times 4 is 24, and then 24 times 10 is 240. And then do the same thing for the little box. Well, we know that this part right here is the length, but we can find that information behind it, which my length would be 4. So the slant line is my width. Well, if I continue and look at all those slant lines, I see my number back here on the bottom prism, which was 6. And then they do tell me my height back here is 3. So now I'm going to take my 4 times 3, which I know is 12, and 12 times 6 is 72. And I'm going to add those two numbers together. So 2 plus 0 is 2, 4 plus 7 is 11, 1 plus 2 is 3. So my final volume is 312 cubic centimeters. Moving on to the last page. So your book is a little bit different than my page right here. Notice for C, this word on your book is sometimes. I want you to change that to the word never. And now we're going to go ahead and fill in the number or the words from the tiles to complete and make each statement true. So for A blank is always a parallelogram. Well, I'm going to make sure I look at my choices. I know a trapezoid isn't going to be right there because my trapezoid was never inside the large parallelogram picture. But I know it can either be a square or a rectangle. So I'm going to have to make sure that I look at my other sentences to make sure I'm choosing the correct one. So I know A is going to be either square or rectangle, but I'm going to look at B before I make my final decision. B says a blank is always a rhombus. So if I recall back to my Venn diagram or my web that we made, I know that between the square and the rectangle is again what I'm going to be having to choose from. And I know that my rectangle could never go into my rhombus category. So therefore, because I have that word always, I'm going to have square in B. So then going back up to A, I know that rectangle would always also be a parallelogram. And then finally C, a blank is never a parallelogram. Well, we know that that was our trapezoid. The trapezoid club never got to go to any others. So trapezoid. Moving on to number 16, I'm going to actually cross this one out. And then number 17 is going to be the next question. Number 17, Ken keeps paper clips in a box that is in the shape of a cube. Each side of the cube is 3 inches. What is the volume? Well, if it helps you, draw a picture of a cube. So I'm going to draw 2 squares that are kind of overlapping each other. And I'm just going to connect them so that way I have a cube. Now it says that each side is 3 inches, so I know that my length would be 3, my width would be 3, and my height would be 3. So to find my volume, I'm going to take 3 times 3 times 3. Well, 3 times 3 is 9, and then 9 times 3 is 27. So my final volume would be 27 cubic inches. Now going down to question number 18, this is the last question that we will have. And in this question it says Monica used 1-inch cubes to make the rectangular prism shown. For A through D, write the value that makes each statement true. Each value can be used more than once or not at all. So for A, it says each cube has a volume of blank cubic inches. So we're just talking about one cube. So if I just look at this one cube right here, so my one cube right there, they tell us back up in the question that they're 1-inch cubes. So this would be a 1 by 1 by 1. So if I take 1 times 1 times 1, I know that the volume of 1 cube is 1 cubic inches. Because again, I took 1 times 1 times 1 to get that. Now for B, it says each layer of the prism is made up of blank cubes. So we need to find the area of our base. So I see that I have 4 inches by 5 inches right here. So if I take 4 times 5, that's going to tell me the number of cubes that are in the bottom layer. And I know 4 times 5 is 20. Then for C, there are blank layers of cubes. Well, they tell us right here that there are 3. So we have 3 layers of cubes. And finally for D, to find the volume. Well, if we have 20 cubes in the bottom layer, and we have 3 layers, 20 times 3 equals 60 cubic inches. So our test is very similar to this that we will be taking on Schoology. There are 17 questions, which will have a total of 50 points. So please make sure you are reviewing your polygons, the side angle vertices with their names. Make sure you're reviewing your triangles, your quadrilaterals, and then obviously volume with your length, your width, and your height. If you have any questions, please let us know.